This so-called special talk will not be about geophysics, but more or less related with education, geophysics education. Maybe at the registration, you folks received the brochure with the name QLT and wondering how that is related with this conference. So this is a chance for me to explain how I will use disability to tie with earth science. Okay? 됐나? 물 한번 주시겠어요? It will not be a 20-minute talk. I think it will be shorter. What did I say?
네, 제가 하겠습니다.
Okay, I just thought I should let you know why we are interested in computational science and this and how it might be related with the educating students with disabilities. The title is Achieving Universal Design in Higher Education through Undergraduate Interdisciplinary Programming Computational Sciences. Next. First of all, universal design. This is what I pulled up from Wikipedia. It's like the concept came from architecture. So if you design a building that is helpful, accessible, and helpful to people with disability, it will not only be beneficial but to non-disabled people as well. A typical example would be an elevator at the subway station. People first started implementing elevators at subway stations, and nowadays, for people with disability, but nowadays, more people, non-disabled people, much more of them use elevators. So if you design or make a product that is helpful to people with disability, it will not only help them, but will be helpful for the rest of the people. That is the concept of universal design, and this is taken up in designing many products, electronic product, consumer products around the world. And we thought we can implement this idea in higher education, meaning college education as well. Next. Well, many of you may know, but this is what happened to me 6 years ago in California when we were driving towards Death Valley. Death Valley, fortunately, was like 5 hours away, and this is what happened to me at Carrizo Plain National Monument in California. This picture shows me crushed at the driver's seat, and that time the van roof collapsed, and that's when I had my injury, accident. And I tell people that if you don't want this happening, drive Volvo. Next. Despite the injury, I am paralyzed, neck down, and I cannot use my hand or feet. Still, thanks to computer and modern technology, I'm able to do almost everything that I used to do before. For instance, even though I cannot use my foot, I have wheelchair and accessible van, which takes me around. So I do not miss my foot very much. And even though I cannot move my hand, with this special device that I can use by sipping and puffing, I can manipulate computer. And once you're on computer, there are so many things that you can do. So I often call computer as a God's gift to people with disability. You know, when people see me use computer, they're amazed how I can do this. So even though people think that I lost much of my capability, in reality, thanks to computer and these modern technology, I could still function and do science. Next. So life has unusual twists. This accident happened 6 years ago, and then I returned back to Korea and started working in 6 months. And this caught the attention of media in Korea, because in Korea, people with my level of injury would stay in hospital, could stay in a hospital forever. And I found out that that's because the medical cost between United States and Korea is about 15 times, 1-5. The medical cost in United States is 15 times higher than in Korea. So when the people get injured, like myself in Korea, they can stay in a hospital forever without too much worrying about the medical cost. But in my case, because I was injured in the United States, I had to get out of the hospital as fast as I can, and people thought that was very determined, and then so I became instant celebrity when I came back to Korea and started working. And about 4 years ago, I had a chance to write a column in Korean newspaper, and after I wrote this column, somebody in the government was very impressed, and he came to my office and said the government wants to do something related with disability issue, and offered me $10 million a year for the next 10 years. And so suddenly I was, besides doing earth science, I had another problem of how to use this $10 million a year effectively. Next. We decided to use this money to develop technology for people with disability. And since I'm not an engineer or developer, so we gave these 8 projects to different companies, and they came up with various devices to help people with disability. And below is a Galaxy Tab, which is a little bit different from Apple, developed by Samsung. I told people at Samsung Electronics that I hate Apple, iPad, iPod, iPhone because I could not touch. And then they made because Samsung is in competition with Apple, they made a special Galaxy Tab that I can use with by sipping and puffing onto it. So next. Well, it's in Korean, but another thing we realized was that many students with disability in Korea, for instance, in our university, at Seoul National University, we had at that time we had 60 students with disability, but 80% of them took major in social science, humanity, and arts. So only less than 20% of the people, students with disability, entered into science and engineering. And so we thought that we can change this, and so we decided to devote some of our effort in not just making hardware products, but putting into education. And we decided to make the second line, the undergraduate computational science program at Seoul National University, because science is about observation and experiment, but some observation and experiment, as you all know, are practical or impossible to do in real. So we thought that another way that students with disability could participate in science is by doing computational science related to computer programming and these things. For instance, nowadays in chemistry, just doing simulation, you can sometimes, before making the actual product or testing, you can understand the property of the material. So computational science, although it's very pervasive in all fields of engineering science, and so we decided to make a undergraduate program in computational science, and that was one of our 6 area of focus that we decided to do. Next. And so this is actually a web page shot of this undergraduate program, and at first it was very difficult because Department of Mathematics and Engineering, Computer Science did not want us encroaching their field. They thought it was their field, but we managed, and with the help of many professors and also David Yuen here, we're able to establish a Department of Computational Science just last year. And it's been a little over a year and a half since we have run this program. Next. There were similar computational science program in graduate school, but this is the first time that we were doing. And our idea was that when you try to teach math and computer to students with disability, meaning physical disability, blind, hearing disability, you have to come up with supplementary materials and make the entry easier than the traditional math and computer science. So it's like building a ramp instead of a step. And we said if we do this, we'll attract not only students with disability and give them opportunity, but also students in social science and engineering who has traditionally shunned away from computational science because they were afraid of math and computer programming. So our goal is to make computer science, teaching education of computer science accessible to the student with disability, that it will not only help students with disability, but by providing transcripts and captioning and all this related material, this would attract students in non-science into science. And we are seeing some effects of that already. And another thing is that when you talk about computational science, people think about fluid dynamics and traditional fields of numerical analysis. But in our case, we enlarged it to include so-called data science, which we have been doing as a geophysicist, but suddenly it becomes a very catchy phrase to attract students in social science and humanities as well. And also to attract students with interest in art, we have also put in computer graphics and animation in our curriculum. So when you say computational science, we usually mean numerical analysis related things, but in our case, we diversified and put these 3 programs in undergraduate program. Because, you know, this is an undergraduate program, and undergraduate is about exposure and diversity, and maybe they will, when they go up to graduate school, they will, choose one of these areas and focus on it. But as an undergraduate program, we decided to make it, decided to break off from traditional applied mathematics focus program to diversify and include these other emerging and interesting topics. And so our goal is what I call it, not Superman save the world, but student with disability save the world. Because with the when you have disabled person, it is the government has to, or the public sector, use a lot of taxpayer money to support them. And we thought that computer science, making them into a good programmer in commercial product field in the private sector, still makes them very difficult to compete in the private sector with non-disabled people. But science, it takes a lot of learning and a lot of investment, but our goal is to make them into scientific programmer, not as opposed to commercial product programmer, and make him into science teach students with disability to become scientific programmers so that they would then be able to contribute to the public science. What I call public science is science related with global issues like energy, resources, environment, spread of disease, all these things that require knowledge for government to make policies. So our goal, our dream is that someday, by giving opportunity to students with disability and exposing them to computer science, they would somehow become a proficient programmer, and then what their work would contribute to the wellness of the public sector, which they are indebted to. So to sum this work up, our catchphrase is "Disabled person saves the world." So this is why we decided to use this opportunity to produce, to promote computational science in the undergraduate level at Seoul National University. Thank you. Yes, as a means of universal design in higher education. Yes. Any questions here? We are still far away because we just began this program only a year and a half ago, and although we have this grand noble idea that still attracting students and getting the word out is slow, and it takes a lot of time. Yes, yes.
From my experience in Japan, I know that Japanese students have a lot of problems learning English. And I think that's probably also true in Korea. Anyway, that's my extrapolation. So I'm wondering, in your program, in addition to teaching mathematics and things related to that, computer science, are you making any special effort to teach your students foreign languages? Maybe that's one way you can give them some competitive advantage compared to the ordinary Korean students, if you could get them to be really good in foreign languages.
I have not thought about that yet. So I thought, in Korea, at Seoul National University, many students in engineering and science can go to social science because, but many students in social science or humanity, when they find science interesting, they are afraid of the fact that they have to learn mathematics and then computer. And traditional department has not been very well in attracting them. Like, so we have only focused on that, but not on the language yet. That's a good point, yes. Okay, yep. Thank you.